Now this theorem says, given any two chords of a circle, any two chords, the one which is nearer to the center is greater than the one more remote. What this means is, let us say this is any circle and let this be any chord, okay, at a certain distance from this center O. So if I take any other chord which is nearer to this center, right, that means this distance here is lesser than this distance, right? So this distance is lesser than this, so this chord will be greater than this chord in length, right? So as I approach near the center, I'll have larger chords than these. So what will be the largest chord? That will definitely be the diameter. So diameter is the largest chord that I have in any given circle. Okay, so how do I think about it? I draw a circle, right, and I take any two chords at different distances. That means if this is center O, this chord AB is at a distance OM, let us say. When I talk about distance between a point and a line, I am talking about a perpendicular distance, right? And let this be point N, and this will be chord CD. Now if I am saying that OM is lesser than ON, that is this distance is lesser than this distance, then I need to check whether AB is greater than CD or not, right? Now as per this theorem, if the chord is nearer to the center, it is greater than the one more remote or the one more far away. So in this case, I have taken OM as lesser than ON, and I need to prove that AB is greater than CD. So how can I think about it? I will join OA and OD, right? And I will apply simple Pythagoras theorem. Now OA and OD are radii of the same circle, so these have to be equal, right? But in these two triangles, these OA and OD are acting as hypotenuses. So if I talk about this triangle, OD squared will be equal to ON square plus ND squared, and in this triangle OA squared will be equal to OM squared plus AM squared, and OD and OA are equal to each other because these are nothing but the radii of the same circle. So these two equations are equal. So this part, the right hand side, ON square plus ND square is equal to OM square plus AM square. Now if you look at this equation and think about this, that OM is lesser than ON. This OM is lesser than ON, right? If OM is lesser than ON, then for this equality to hold, AM should be greater than ND. AM should be greater than ND, right? Hence, I can say for this equation to hold, for this equation to hold, if OM is less than ON, right, then AM should be greater than ND, right? And what is AM? AM is half of chord AB. So AM is nothing but half of chord AB. And what is ND? ND is nothing but half of chord CD, right? So I can say AB should be greater than CD for this equality to hold, right? AB should be greater than CD. So this is a simple analysis using the Pythagoras theorem. If somebody doesn't understand why this equation will hold when if OM is less than ON, AB should be greater than CD, you can simply think about like this. Let us say 2 plus 3 is equal to 1 plus 4, right? This is an equation because this is nothing but 5, this is nothing but 5. So if 1 is lesser than 2, So there should be a number which is greater than this number, right? You can write these simple numbers and think about this. All right. So we can say that given any two chords of a circle, the one which is nearer to the center is greater than the one more remote.